Section 4.3, Example 3 on page 249. In problems 1 and 2, a variable is eliminated because the sum or difference of its coefficients is 0. From the multiplication property of equality, you know that you can multiply each side of an equation to get a new equation that is equivalent to the original. That is, a plus b equals c is equivalent to d times a plus b equals d times c, or dA plus dB equals dC. Since this is true, you can eliminate a variable by adding or subtracting if you first multiply an equation by an appropriate number. You can prove that the results are the same simply by substituting the values for the variables into the original equations to show that the equations are true. Example 3 says, what is the solution of the system? Use elimination. We have negative 2x plus 15y equals negative 32 and 7x minus 5y equals 17. Up at the top, I put the reminder that first we want to create a variable with the same coefficients but opposite signs, and then we want to add straight down. Again, it's important to label our equations so that we can refer to them easily. In equation 1, we have a negative 2 in front of our x and a 7 in front of our x for equation 2. In equation 1, we have a positive 15 in front of the y, and in equation 2, we have a negative 5. None of these match as far as the numbers in front of the variables, and this time it's not just a matter of switching it to a positive or a negative. However, one of the variables is easier to get matching values than the other. We can't easily make 2 look like 7 or 7 look like 2 by multiplying by a whole number. However, we can make 15 and negative 5 look the same by multiplying negative 5 by a positive 3. It's not required that you multiply equation 2 by 3. You could have multiplied equation 1 by 3.5, but then we would have a bunch of decimals. So it's important to first take a look and see which variable would be the easiest to manipulate in order to get what we're looking for. If we decide to multiply equation 2 by 3, we need to multiply everything in equation 2 by 3. So we have 3 times 7x will be 21x, 3 times negative 5y will be negative 15y, and 3 times 17 will give us 51. This is going to be our new equation 2 that we'll use for step 2. Step 2 is to add the two equations straight down. So we're going to keep our original equation 1, negative 2x plus 15y equals negative 32. And now our new equation 2 is 21x minus 15y equals 51. If we add straight down, we have negative 2x plus 21x gives us 19x, 15y minus 15y gives us 0, and negative 32 plus 51 gives us 19. Our goal is to get x by itself. Right now we have 19 times x. The opposite of multiplication is division, so we're going to divide both sides by 19. 19 divided by 19 gives us 1, so we're left with 1x or just x. 19 divided by 19 again is 1, so we get x equals 1. We can use the x equals 1 to plug this into either of our equations or our new equation 2, whichever one we want, and we can solve for y. I chose to use the original equation 2, but regardless of which one you choose, you should get the same answer. So equation 2 said 7x minus 5y equals 17. If we plug in our value for x as 1, we get 7 times 1 minus 5y equals 17. 7 times 1 is 7. And then we have 7 minus 5y equals 17. We're trying to get y by itself, so we can subtract 7 on both sides. 7 minus 7 gives us a 0 pair. We're left with negative 5y on the left, and 17 minus 7 gives us 10. Now we have negative 5 times y. To undo multiplication, we're going to divide. So again, we're not adding to both sides. We're going to divide by negative 5. Negative 5 divided by negative 5 gives us 1, so we have 1y or just y. 10 divided by negative 5 is negative 2. Now we have an x and y value. Therefore, our final answer is the coordinate xy with the values 1, negative 2. As the previous slide states, it's always a good idea to plug these values back into your original equations to make sure that 1 and negative 2 do work for both equation 1 and equation 2. The work for this problem is written out on the next two slides. And now I would like you to try number 5 on page 250. Solve each system using elimination. We have 3x plus y equals 5 and 2x minus 2y equals negative 2.